आइए हम सुने विज्ञान की अनकही कहानियाँ। आइए हम सुने विज्ञान की अनसुनी कहानियाँ। एक नई दुनिया की आवाज़ आपकी आवाज़, विज्ञान की आवाज़, की आवाज़।
Celebrating Azadi Ka Amrit Mahotsav, we bring you a podcast series on STEM popularization, science, technology, engineering, mathematics and medicine, supported and catalyzed by the National Council for Science and Technology Communication, Government of India. This program is produced by Media for Community Foundation. Creative content and technical support is given by Purvasha Banerjee and Shushanto Das.
एक नई दुनिया की आवाज़ आपकी आवाज़, विज्ञान की आवाज़, की आवाज़, की आवाज़।
Indian Statistical Institute is a public university which is recognized as an institute of national importance. It grew out of the statistical laboratory set up by Prashanto Chandra Mohananobish in Presidency College, Kolkata. Established in 1931, this unique institution of India is one of the oldest institutions focused on statistics. Primary activities of ISI are research and training of statistics, development of theoretical statistics and its applications in various natural and social sciences. We welcome Dr. Pradip Bhattacharyya to this episode. Sir is an associate professor working at the Agricultural Ecological Research Unit, Biological Science Division in Indian Statistical Institute, Giridih. Sir shares about his vast experience in research.
I am Dr. Pradip Bhattacharya, Associate Professor working in the Agricultural Ecological Research Unit, Biological Science Division in Indian Statistical Institute, Giridih, Jharkhand. My research experience is about 25 years and I am working on basically the waste management, environmental pollution and their mitigation option, soil quality, soil chemistry and soil health.
In this episode, Sir focuses on the process of waste management and its significance. He talks about how his research unit has been contributing in this field as well as about various collaborations.
Today, I am discussing about the waste management. And waste management, it's a conversion of the waste to the oil. The different waste we are producing day to day, industrial waste like municipal solid waste, brick kiln waste, sewage sludge waste, tannery sludge waste, etc. So these waste contain lots of heavy metals and they are toxic to the human being and we can't use that waste directly to the agricultural field. Nowadays we are producing the organically growing crop. And also for the organic cultivation, cow dung is the best organic manure. But due to the paucity of the organic manure, we have to explore the other organically manured and that manure, it's not easily available. So we can convert that organic waste to the organic compost. But problem is that this waste contain lots of toxic metals. So we are actually converting that waste to the vermicompost with the help of the earthworm. And that earthworm is generally available with the farmers and that earthworm is called the Eisenia foetida. And that earthworm converts that toxic waste to the valuable compost. Now question over here that what about the fate of the metals? That metals enter into the earthworm gut and earthworm gut contains lots of protein and that protein bound the toxic heavy metal And when that toxic and that excreta released from the earthworm, which is called the vermicompost, that metal, it's not available, it's bound to the organic form. So that organically bound form, it's not degradable by the microorganisms. So there is a complete lockdown. So we can't convert to the arsenic to the phosphorus or nickel to the nitrogen. What we can convert, the change of the compartment from the availability to the non-availability. So vermicompost is much more safer, and that vermicompost we can use for the crop cultivation. So in the Giridih, we have converted the different waste like brick kiln waste, like sewage sludge waste, like municipal waste, like tannery sludge waste, everything, and also the mine tailings to the vermicompost with the help of the cow dung and the earthworm. And when we have applied that vermicompost to the plant like rice, vegetable crop, etc., we got there is no metal present in the edible portion of the crop. That is, there is no metal in the rice grain, there is no metal in the rice straw or the other vegetable crop. So that means that vermicompost farmers can easily use for their crop cultivation. So farmers, they can easily use that technique. So we have already transferred that technique to the Jharkhand based farmers, and they have already doing that thing. So they have the earthworm, we have supplied that thing earthworm. Suppose if we have supplied the 100 earthworms and they have used the cow dung, because cow dung their food. So within 3 months, this 100 earthworms converted to the 1000 earthworms. So by that way, they can replicate or multiply the number of earthworm, and with that help of the earthworm, they have already converted that waste materials to the vermicompost, and that vermicompost they are applied to the crop as a organic amendment. So they are producing the organic grown crop. So by that way, our research is very much beneficial for the common people. And in India, we are National Importance Institute, and we are doing this kind of research, and also we have collaborated our research with the different universities in all over the world, like the Salford University of UK and Stevens Institute of Technology and Michigan Technological University of United States. So we have published our research findings to the very good impact factor journal like Science of the Total Environment, Elsevier Science. The impact factor is almost 10. We have published in the Journal of Cleaner Production, the impact factor is 11.0, and so on. And also the students already published their thesis. I mean, they already got their degree with this kind of research work. And also we are also going to patent this thing, and so this is a holistic approach to convert that waste to wealth.
Sir focuses on the progress of waste management research in India.
India is doing the very good amount of research in the waste management, and they have already from the published paper in the various research journal, very good journal. So they are publishing a good amount of paper, but the uniqueness over here that generally the paper represent from the India, it's a organically the vermicompost and organic compost from the vegetable waste and other waste, but the toxic waste like mine tailing and also that our tannery sludge waste and other very toxic waste, this conversion of this thing to the vermicompost and applied it to the crop cultivation and judge whether that vermicompost application, the edible part or the non-edible part of the crop grown with this vermicompost, whether they have the toxic metal accumulation or not. This is very unique of our research.
Dr. Bhattacharya talks about other contemporary research endeavors.
Who are contemporaries, it's a different, actually this thing, the China is going good amount of research, but they are not actually doing research with the mine tailings. So this is the actually first time we are doing this kind of research, the mine tailings, from the mine tailings, because mine tailings also contains lots of heavy metals and the very toxic metals, and we have converted this thing to the vermicompost, and that's already published in the good impact factor journal.
Sir talks about the implication of his research for the Indian industries and also for the greater welfare for the people of India.
Indian industry, because we already converted the steel industry's solid waste, that the steel industry in Giridih, the Mongia steel industry, Saluja steel industry, so in his steel industry generated the steel slag, and we have converted that steel slag in the vermicompost, and the paper already published. So we have solved this problem issue, because the steel slag they have generated is a huge amount. So they are actually dumping this thing in the nearby agricultural land, and that is actually polluted the land. So this is the first time in the world science history that we have converted this steel slag into the vermicompost. So by that conversion, and also when we have applied that steel industry vermicompost to the crop like green gram or the black gram, so there is no accumulation of the metal of that particular crop. So the people, the steel industry can use that steel slag, toxic steel slag, because toxic steel slag contains lots of metals like nickel, like manganese, like chromium, etc. So it's already, when we have converted to the vermicompost, it's in the locked condition. So there is no available nickel, manganese, chromium, etc. in the vermicompost, and by that way the steel industry already using this technology, and the other steel industry in the all over the India, they can use that technique. By that way they can solve their waste problem.
We feel enriched to listen to Professor in this episode where he shares about his research.